fourth session of us building our simple calculator, and today we finally bring everything together and use our mathematical representation, our calculator logic and our UI to finally build the calculator. So this session will be without any lecturing, just diving right into the code and connecting the calculator with the UI. Okay, without further ado, let's try to get started. So, this is the UI we built in the very first session. I already started the simulator, and the one thing that's still wrong is that nothing works. So we're going to build our view controller class for this calculator. If you remember, the view controller has the task to manage its views and get the actions from the inputs, so from the buttons and all the other kind of components you can place, and display some other stuff and do some calculations, whatever you want, using the model or the logic, which is our calculator, and display the result to the user using some kind of other views. In our case, the label where the numbers are shown. In order to change stuff on the view, we need to have variables, or better, properties that reference our views so that we can access them from our view controller. When you start a new project in Xcode, Xcode will provide you with one view controller which is already connected to your view controller in the storyboard. Just saw that the chroma key is not working correctly, but yeah, so it is. If you look at your storyboard and you go to your view controller, you find up here in the identity inspector, you find the class that is connected to this view controller. And this is actually the same class as the view controller, which is started to getting implemented by Xcode here. So our first task is to give ourselves some properties that are connected to our label that we want to show some stuff in. So we do that by creating special properties, so to speak, which are called outlets. And an outlet is basically a connection from a view controller to its storyboard views or elements that you can position in the storyboard. So Xcode provides it by default. Yes, the first view controller, if you start a new project, will be provided, but you can of course add new view controller classes and add new view controller elements to your storyboards. So because we just have one view controller in this little app here, we won't cover this here, but I think maybe I will do another project which will encompass or incorporate more than one view controller, and there we will cover that. So let's start with creating an outlet. There are different ways to create outlets in Xcode. One is a pretty simple way where you just have a drag and drop solution, which I show first, and later I will show another solution just by writing the code oneself. So to do the drag and drop selection, you can change from the normal view and to a assistant editor view, which brings you two columns of content in your Xcode. I just hide the left and the right bars to have a little bit more space, and the bottom bar as well. So just by these three buttons here, you can toggle the views. And I will now go over and select up here what I want to see in my assistant view. And there's one really interesting things. Let me see if I find it. Sometimes this is a little bit messed up, so it doesn't always show me the stuff I want to have. So let me just see if I can figure out what he's now having a problem with. Siblings, superclasses, counterparts. I was hoping for the storyboard to pop up in here, and this is actually not really helping. So if that happens to you, one good way to open a different file in the assistant view is by holding the Alt key and clicking the stuff you want to see. So you hold Alt and click on main storyboard, and then it shows up. So that's what I was looking for. That's what I wanted to have. So getting rid of that here, and now we want to have a connection from this view to this code, and we do this by selecting the element we want to make a connection to. You can do it here as well. This is the view hierarchy, as you know from the first session. You hold the Control key and you drag over to your code, and you see this line appearing, and you let go, and then it tells you that it wants to connect an outlet, which you want to. You can give it a name. The type, like the data type, is a UI label. That's the class of this element. And storage weak, we leave it that way. This is another would be another topic that would bring us too far away from our main purpose right now. So leave it to weak. That's in most cases that is correct. And then we give it a name. So I like to give it a name where I can read out what kind of view it is. So it's the display, and it's the display label. So connect. So the question is, what's storage for? Storage basically has a couple of different, let me just do this again, different properties here, weak and strong, and it basically means how can I make it quick? So weak means that the link we're producing here is not preventing the view controller to be thrown out of memory, basically. Or, sorry, I got this wrong way. Weak means that the label can be deleted from the memory by some other system, the UI system, without our view controller clinging to it. So that's important. If your view controller goes into background, the iOS operating system basically cleans off a lot of the views to make space in the graphics memory. So as soon as you bring the view controller back up, the system behind everything will make sure that your views are in place. But if you put it too strong, this link would prevent the operating system from cleaning off or cleaning out your views, which might or might not be really useful. In most cases, if you're dealing with views and outlets and storyboards, weak is totally fine, and the rest will get managed for you. So now we have a variable where we can access, and there are different predefined methods here. So one is view.load, and one is did receive memory warning. So this really quick, we don't need this, so I can delete it, but before I do it, did receive memory warning gets called when the iPhone runs out of memory. So it gets called for all the running apps, and the apps and the classes or the view controllers that are currently in action can now discard some of the memory they allocated because I don't know, some caches or whatever stuff you have. Here you can get rid of it, so you make free for other apps of other processes on the iPhone. If you don't do that and your app is one of the most memory consuming apps, it will get killed by the operating system. So since our calculator has so much different cache stuff and lots of memory hanging on to this View controller, we just can get rid of it, and if we find that we need it later, we can just put it in there again. Okay, so ViewLoad. ViewLoad is a method that gets called as soon as your View controller is ready to be shown. It's not on the screen yet, but it's ready to be shown. So ViewLoad means that all your views are already in the memory and all your connections to the views are already in place. So you have to think about that. There's a loading phase where the views get set up, where the class for the View controller gets set up, and then they get connected. And ViewLoad is called as soon as this connection is in place. And this is the time where you do some additional initialization for your views. For instance, we can try out now. If we have our display label, we can set a text on it and see if it changes when we recompile and start the calculator. So we just go self display label dot text equals to hello world. Then I go Command R for run, or hit the play button up here. Wait a couple of seconds and hopefully we'll see a calculator saying hello world. So that worked. So now you see that we have a connection from our code to our label. So this makes no sense, so let's get rid of it. Okay, so what we want to do is, as every time a number is touched, so that's our first step, we want the number to appear here in the display label. So there's another kind of connection between View controllers and the storyboard. The first was the outlets, and the other one is actions. And actions are specific methods that you can assign to certain actions that are done onto the views. So if you have a button, there are a couple of actions that you can say, okay, when this happens to the button, but please call this method, I want to do something. So we need a method here which gets called every time we tap a button, a number button. So we just go on with that for now. So we can do that the same way as we did it with the outlets. We go in here, we hold Control, we put it on in here, and then we change the connection type from outlet to action. And we give our method a name. I call it number touched. And we then can specify what kind of parameters we want to have. So we can say we want a parameter. So like arguments, like parameters is the same as arguments. We can say we want to have the sender of this, the sender and the event. So who's done action to and what action is it? Just who's done action to or nothing. So we want to have the sender because we want to know on which of the numbers button the user touched, and we don't want to have a separate action for each of the 10 number buttons. So Wetrix asks, what is an outlet? One moment, I will come to that in a second. Let me just finish the action here. So we go in, we want to have the sender, so on what button we touched, and we want it to be of a type UI button, because these are all buttons. Connect. So now I have a IB action. IB stands for Interface Builder, which is basically the old name for storyboards, like really colloquial speaking, so it's not really precise, but it's like this system here. And every time I now touch on the 7, this method gets called and something happens. So let us just test that. So I do a print, which lets me put stuff here on the console, and I just put in 7 touched. So I run it, and we will see if this appears in the log when I touch the 7. And there it is. Every time I touch the 7, this appears, so we know as soon as I touch the button, this works. Good. So before we go on, Weetrix asks, what are outlets? So outlets are basically connections from the view controller to the storyboard. In that case, in that sense, that we define a variable which holds a reference to a certain view. In our case, we have this variable display label of type UI label, which is, after the view is initialized, this label here. So everything I do to this variable in my code, like for instance, as I showed before, setting display label.text to hello world, will affect the view that was set up in the storyboard. So if you look here, you see when I touch this and go to the identity inspector up here, this blue thing, you see that the class is UI label, the class, the data type. So this matches. And when I go here to connection inspector, you see there is a referencing outlet of display label to view controller. So this goes to this. So this goes to this. So this is how this plays together. I hope that makes sense. So now we have the 7 touched. So, but we want to have that for every different button. So we could go on and do this here. And go in here and create a new action and go in like, I don't know, 8 touched. And we put in the same stuff and here and everything. And now we could do something for the 8 touched. And we could do that for all the buttons, but that would be pretty lame. So we will remove this and make sure that we also remove the connection. So if you go in here and you see here 8 touched, and this is actually, if you run that, this would crash the app because the method is not there anymore. So we can delete that. So we should delete that. So what you want to do instead is that you want to connect all of these buttons to this function here, this method. So we can just control drag and control drag and so on. Okay, now you see we have connected all of these buttons to this one method. So if I run the calculator now and I can touch any of these buttons, this little print message should be shown. So here we go, down here. I have to hit the 4, 7 touch, 6, 2, 3, 0. Okay, so yes, all numbers the same line of code, but the numbers are, the line of codes actually are wrong right now. So let's get rid of that. So of course that makes no sense. That was just for a little bit of a demonstration here. So what we want to do is now we want to figure out what kind of number we touched and want to add it to our little label here. I know already how this turns out, so I will add a new function which will do the adding of the number, of the digit. So I have a private function, add digit, and let me just look, and this is actually like, let me make this string. So we have a function which is add digit, and we want to set the display label text. We want to change that to be we want to add the numbers we're typing to the display label. So we have our variable here, display label, and we want to do stuff depending on whether we have. So let's do that step by step. We set the display label text to be the digit we just entered. If the display label text is not 0, we will text append plus equal is an operator, which is basically a short form of display label text plus digit. If you remember the second session we did, you can add a string to a string, and this way you can append one string to another. So this is here an interesting error which we have to figure out. So if you look at this, so the display label UI label has a text property, and the type of the text property is actually not shown to us, but I know it's a string optional. So it's really like telling me, okay, either you know that there's something in this display label text, or you better find a way to solve that if there's nothing in there. So we know that there's always a 0 in there at least. So we can just put in a exclamation mark, which will unwrap the optional if you remember session 2. And this way we have a string plus a string and not a string optional plus a string, which will give us an error. I hope that makes sense. Let's see if that works, at least a little bit. Oh, sorry. I was a little bit getting ahead of myself. So we have this function here, but we need to call the function, of course, every time a number is touched. So we get the sender here, which is the button we touch on. And we know that the button we touch on has a title, and the title is equal to the number we touch on, because it shows the number, right? So if I have the sender and I go to title, like here, current title, I have the 7890 whatever. And if I now call my new function add digit, which is the current title, I then hopefully have the first little step towards a calculator. 7, 8, 9, 5, 6, 2, 3, 0, 0. So nothing else is working, so I just okay. So if I type 0, okay, nothing happens. That's good. Comma, nothing happens. 3, 2, 0, 3. So that seems to work pretty well. Good. So we can type time. So for now only numbers work. Yes, for now only numbers work, because we haven't added the other buttons yet. Okay. So we can add numbers here. We can add another simple button, which is the AC, so the all cancel button, which just resets the display to 0. So in order to do that, I showed you the method of control dragging the button to the code. Another way is to just start writing IB action func all cancel, that's AC, touched. And for this method, I don't need to know which button it was, because I know it's always the all cancel button. So I just give myself no arguments here. and in there I will do self label display label text equals to 0. And now I have a method which is not connected yet to the button, and I can now go from this little thing here and drag this to my button. And this is another way to connect it. Yeah, sometimes so. Much easier to just point and drag. Yes, sometimes it is. Other times it's not. If the storyboards are getting really big and really slow, it's sometimes a little bit more easier to just write out your functions and later connect them. In this case, it's so small, everything is good. So if I hit this, nothing happens, of course. If I type something in and hit this, it gets reset to 0. So basically what we can do now is not much. We can just type in numbers and clear them. So now let's get back to a little bit more interesting stuff here. What is good? Okay, so if you remember correctly, we have our calculator, which I haven't yet put in here. But we created the calculator last time in our storyboard, in our playground. So I really quick opened the playground from session 3. Here it is. Open the playground app. So that is what we did last time. And I need exactly all of this. I need the calculator, I need our mathematical representation, and I will put this simply by copy pasting it. After we tested it in the playground, I just get this and put it inside of my project. I will create a new file by selecting the folder I want to create the file in. Tab new file, Swift file, next. I call it calculator, create, and put this in here. So now we have the calculator and everything should be fine. I think we have a, oh yeah, we have a git here. So let's do some committing. So in order to have a good progress of our project, we need to do some commits here and then so that we can go back. And for this little project, I wouldn't need it, but most of the time I have a git in the background to do my source code control. Like we set up in the first session, I guess. So the first thing we did was we connected our display label, added the number touched and the all cancel touched, and added the add function. So we added a basic entering number functionality. Suck. So next we add the calculator class, added the calculator logic class. That's not a class, calculator logic. Okay, so everything is committed. Let's go back to our view controller. So if you remember from our calculator, what it does is it evaluates a stack of tokens, where tokens can be either operands, so entered numbers, or it could be operands, so plus, minus, divided by, multiplied by, you know what I mean. So now we have to figure out a logic how we can implement the typing in numbers and put it into our calculator logic as operands. So an operand is basically separated, and I showed that a lot in the slides with the examples we did, by hitting an operator or hitting the equal sign. So if you type in a formula like 2 multiplied by 5, you tap on the 2, hit the multiplied button, and then we know, okay, the 2 is our first operand. Multiplied, the first operator, and 5 equal, 5 is the second operand. So this is how we can discern between entering numbers and saving them to our calculator logic. So let's do that. Let's add a function here before we add this to our actions and stuff, which we need to do. We will just start with a little helper function, which is called add operand. So this function is basically doing if self.displayLabel text question mark is, so we know it's never empty. So if it is not empty, so basically we're calling the IsEmpty method on the text and the label, which gives us true if it is empty, and we negate that with the exclamation mark. So everything with an exclamation mark in front is negated, so true becomes false, and false becomes true. So if this here is true, so basically if it's not empty, we do this here. And we will do the following. We will type calculate. So, okay, I missed a step. In order to do that, we want to call on our calculator the add with an operand of our self-display text. So that is of course not working, and it's not working because we did have to do a little more work here, but basically that is what we want to end up with, more or less. So the first thing is, of course, we don't have a variable calculator by now. So what we have to do first is give ourselves a reference to our calculator. So we don't need that because we don't need that now. We will need it later. So, but for now we could just call eval on our calculator because it's a static method. So we don't need to have an object of the struct or an instance of the struct. We can use the struct itself to call the static method. So this would work. But now there's another thing that is wrong. We don't have a method add operand. So the thing that we missed here, or sorry, the thing that we haven't implemented yet is we only have implemented the evaluation of our calculator last time, but we haven't implemented all the management of the stack and all the other stuff that the calculator should do. So let's do that now. Let's say we want to have our calculator to have its own stack. Then we could give it a variable, a private variable, which we call stack, and that is of type token. So here we will store all the stuff that we enter into our calculator UI. And we could just make this public and let the view controller write calculator.stack, add stuff and do that. But this is not a good practice. We want to encapsulate our private variables and have it been in one place. Sorry, We want to encapsulate our private variables and want to have method that access them and manipulate them. So a question, what's the stack going to be used for? When we're typing our formulas into our calculator, like this 5 times 2, we want the stack to hold the 5, the multiplied by operator, and the 2, that we can then evaluate our result. So the stack is basically the memory of our calculator, where the different calculation steps are going to put in, which we put in the end into our evaluation function to get the result of the current stack. But I think that makes more sense if we just move on, and hopefully in the end it makes all sense. So we have our stack, and we have a couple of methods there that we're going to use. The first is that we want to add operands to our stack, and or not just operands, more like tokens. So we need a method that adds a token, so one piece of formula, to our intern on our calculator memory, our stack. So we need a function, and all it does is adding a new element to our stack. Stack append or stack append, sorry, new element. So token. So that way we can put a operand like a number or an operator in there, and it will work. So now we get this error which we've seen before. That's because we have a struct, and structs are, as I said in lecture or in session 2, immutable. So they can't be changed normally. So they just get copied from one instance to another, or they just get copied, and then you can use it and give a copy to the other one that can use it. But if you want to change something, you want to change the copy itself, you have to have special rights for that, and you have to define functions that can do that. And for that we have to say that this sorry, not mutable, it's a mutating function. So this function can mutate the calculator. But of course, sorry. So like this, mutating function. So now our function add can actually add something to our stack. So, but this won't work, still don't work. Even though our calculator now has a method add, this is not a static method. This is a method that can only be called on an object of a calculator, so that it has its own stack. Otherwise we can just call the eval function, because it doesn't need this stack. It just uses whatever stack we put in there. So we need a calculator instance. So that is our first time that we declare our own variable, other than just having links to our storyboard. So in the first step we have our outlets. So this is a fancy way of defining little comments, which will add a little separator here in the drop-down menu. I like to do that. So we have our outlets, we have our life cycle. So everything that gets called in the life cycle of our view controller goes in here. We have our actions, just cleaning up some stuff here. And we have our, I call this helper for now, helper methods. So now we have it all nicely with helper, actions, lifecycle. Okay. The next step we have our state. So, and the state is basically the stuff the view controller needs to make decisions based on the stuff that comes into the view controller to make decisions on what has to go out. So one of our state here is our calculator. So we give ourselves a private variable calculator which is actually a calculator. Calling this here is the constructor of the struct as we had it with our persons and jobs in the session 2, and it gives us a calculator. And it wouldn't give us one because we didn't initialize the stack correctly. The stack has to be initialized with something. Or maybe we need our own initializer method, which is totally fine as well. See? No, okay, that worked. So now we have our calculator variable here. But there's still something wrong, of course. Operand is not convertible to calculator. Yeah, that makes sense, because we call it on the struct right now and not on our variable. So we have to do a lowercase c calculator. And this won't work, because now we have a string in here, and this is a double, and we can't put a string into a double, so we have to figure out how to make a number out of the string.
And reappeared.
Okay. So it's pretty easy actually. To make a number out of a string, we cast it to a double. So this doesn't work every time. So if I put in a string like hello world and want to make a double out of it, that's not a number. So how should I know what kind of number I want? So double is a number, so it doesn't work every time. Even though that we know that it should work, we have to figure out a way to give a workaround for the case that it doesn't. So we get a double optional here, and with the double question mark we know that we can give an alternative value if the first value is nil, and so we just give it a 0. So if we can't figure out what the display label text is in terms of a number, we just put a 0 in there. So now that we have the add operand method, we can now use the different operators to actually end the input of the operand and put the operand into the stack of the calculator. And we can do that, for instance,
and reappeared.
When the equal sign is touched and when the operator is touched. Yeah. Let's do it with the equal sign first. So we are here and we want to have our view controller and our main storyboard open side by side. So I clicked on this with the Alt key hold down, and now I will give myself a new action down here, which I call equal touched. And I don't need to know who's the sender, so I can send no in here, connect, and I get myself an equal touched method. So every time the equal is touched, we can just call our add operand method. And the interesting part about that is we won't see anything if I run it, but in the back of everything we can see that it will be added to our stack.
His head disappeared
If I would add a method to show that. So let's see.
and reappeared.
So nothing happens. So let's just so that we just see that it's happening, let's print our stack every time we hit the equal button, or every time we add a token to it, so that we can see it in the log down here. So 9 equals, okay, simple calculator, operand value 9. 6 equal 9, 9, 6. 5 equal 9, 9, 6, 9, 6, it's 5. Okay, of course that's stupid, but now we see that we adding up operands. So, okay, that seems to work. So let's add a new commit here for this. Added a internal memory stack to the calculator and a method to add some tokens. Okay. So what we want to do now is we have some other stuff, there's a lot of stuff to do actually, and just figuring out what is the best way to go about it so that it's making sense to follow this. So let's go on with the operator touched. I think that's the best way to go, and all the edge cases that we have to figure out, we will do that later step by step. So there's a lot of little nifty edge cases that we will encounter along the way. So we just talked about it. Every time we touch an operator, like one of these or the two up here, we want to end the input of our operand and add the operator onto the stack. The operand and the operator. So here we want to have a method that is basically almost the same like this one. So another way of creating a method is just copy this, renaming this into operator touched, getting in here and connecting all our operators with the code. And we use the same method as we did with the numbers. We read out the title of the button and with that distinguish the different operators. So every time we hit an operator, we will add the operand to our stack. So we have that already figured out. So we just call add operand. Okay, and now we have to decide which operator should be after this operand in our memory. So for that we will use a switch statement where we use the current title of the button as deciding factor. In case I haven't mentioned a switch statement, you can think of a switch statement as a lot of if else if construct. So basically we will decide to use a additive operator if the current title is equal to plus, and if it is, we will do calculator add addition. Okay, so let's do all of this. If the case is a minus, we will add calculator add subtraction. If it is the division sign here, we have to get that out of the interface. If it's this little thing here, then we add a division. If it is a multiplication, that's not a simple x, so that's why I get it from here. I put in the calculator add multiplication. So that were our binary operators. Now we do the two unary operators. First we can do the plus minus or negate operator. Negate. And we can do the percent. I think it's a default percent sign. So like this. And we add the percent. So this way we have now all our operators are now added to the calculator, and we are good to go and to see if our stack is actually adding all the stuff in our to our calculator memory. So switch must be exhausted. Yeah, okay. So the switch statement actually has to deal with every case that we throw at it. And we have now a set of 6 different strings that we handle, but a string can be everything. So we have to add a default case which gets handled every time we throw something at it that it can't handle. And I will just do that by printing a message which says unknown operator, and yeah, just put in sender current title there. So that's basically a error handling. So every time we get an unknown operator, it will just print out unknown operator, and whatever we throw at it, it will just show us. So all the other stuff is handled. Let's run this and see if our stack gets filled with operands and operators now. Okay, hitting a 2, hitting a multiply by. So now we have in our stack, the last thing we see is a operand value of 2 and a simple calculator multiplication. Okay, cool. So then we will, what's that basically here? Anyway, next I will minus 6 plus 2, so whatever. So we have 2 multiplication, operand 2, operand 26, addition. So that looks pretty dumb. Why is that? We have a little problem here that we're gonna need to fix in the next step. So any okay, Starlord91 asks, what are the what are the examples that this switch can't handle? Pretty simple. Every string, every button title that gets in here, which is not plus, minus, divided by, multiplied by, plus or minus or percent, so everything we didn't specify here is actually unhandled. So if I do a button where, I don't know, hello is the title, then this switch statement doesn't know what to do. And in that case, it will print out unknown operator hello. So let's go back to our little problem here. So I hit the 7, I hit the multiplication. 7 multiplication. Okay, I hit the 5. Okay, so I don't want to have 7, 5 there. I want to have the 5 there. That's one thing. Then I hit the plus. So I get 7 multiplication, 7, 5 addition. So somehow the stuff that we are inputting is not always the stuff that we see on the display. And we have to make a little distinguishing between our inputs. So we have to make a little distinguish between our inputs and our actual display value. So what do I mean by that? I want to have a new variable, a new state variable, which is a input string, which holds all the digits and all the string stuff that we put into our calculator. So which is shown at some point in the display, but not always. So I initialize this with an empty value. So instead of putting in a digit, instead of putting the input string directly on the display, I want to also add it on my a digit. I want to add it also to my input string. So input string, that guy's input string plus equal digit. So now I have a variable which keeps track of all the stuff that I enter into the calculator in terms of numbers. And then I want to set my display label just to input string. So every time I enter something, I add it to my input string and put the whole input string into the display label. So it seems like a little bit of overhead right now, but in the end I promise you it will make sense that we did it that way. So every time we are now adding an operand, I want to reset the input string. That way I don't lose what is shown in the display, but internally I know, okay, now I'm starting a new number. So what we do is we add the operand to our calculator and reset our input string to an empty string. So if I start this now, I can now type 7 plus 5 minus 3 equals. So now I have a good and clean unknown operator minus. Let's see. Let's see. This is the case it can't handle, and I know why. The problem is that this little dash I put in here is not the proper minus sign I used for the UI. There's a minus sign that's a tiny bit longer than the normal dash. So that is what I used here. So in order to fix that, I have to copy this string from here to there, and yeah, it doesn't look any different actually, and maybe it was a little bit of over engineering here. But if I do it now, this should be working. So if I do 8 minus 2 plus 6 divided by 7 equals, I have now a pretty clean set of tokens. So 8, subtraction, 2, addition, 6, division, 7. So exactly what I typed into the calculator, we have now recorded into our internal memory. And this, ladies and gentlemen, we can just put into our evaluator and get a value from it. So let's try that. So every time we add something to our token list, we actually can actually evaluate the real value of the current calculation. So if you remember how a calculator works, you type in 2 plus 6 and it shows you 8 if you hit the next operator. If you hit the next operator like minus, it will show you the 8, I think. Or it will show you instantly. That's something that calculator. So if you go on this calculator, which looks pretty simple, like so if you do it here in the Apple calculator, we do 5 minus 3 times 9 equals minus 22. Okay. 5 plus 3 plus and here we go. Every time I hit the plus, it actually shows me the value of the stack. So what we do now is to evaluate the stack every time we add something to it. We can do that pretty simple by returning an operand, so like our eval function does as well. And every time we add something to the stack, we will call eval stack. So and return that. So every time we add something to our calculator memory, we get the immediate result back. So we have to write calculator eval because it's a static method. And so every time we are adding we're returning, let me just do something different here. Let me just see what I did as I was planning for that. Yeah. So everything that comes out from our calculator, we can just let it be a double. Because we know that it should be an operand, and each operand has a value, like if you see here, where is it? Operand value double. And we can use this to return the double value of our current calculation. And this way, we can, every time we add an operand, we can update our display label up there. So this is, I think, how we can actually calculate stuff. Let me see. So our display label dot text should be equal to string of a double value, which we return from our add operand function. So that looks pretty long and pretty ugly, and we will really clean that up later. I really wonder how hard it is to make an advanced calculator where you type whole equations. Actually, from that what we have now, it's not that hard anymore. Because our calculator in the back of everything, we keeping a whole equation and at any point can evaluate it. So if we would add some little bit more tricks like brackets, I think, and a little bit more operators, I think we can turn it into an advanced calculator pretty easy. So let's see, if I type a 4 equals 4.0, that's good. 5 equals 0. Why? Because we have now an invalid set of rules here, which is that we have an operand and an operand, but an operand is not an equation, so we can't simply say what it is. That is something that we're gonna fix later. So if I restart this, or hit the all clear button, no, that wouldn't work because we haven't really implemented that yet. So when I go here and type 7 plus 6 equals 13. Works. So why can't I just go with minus now and do 6? I can. 1. I can't start a new calculation because we haven't implemented that yet. So every time I just going from operand to whatever, 9% plus 3 equals 0. Why? Operand, percent, operand, addition, operand. So we have a lot of little side cases here which we didn't really got right now, but we have a really basic calculation here. If it goes 20 plus 6 minus 2 times 9 divided by 8 equals obviously 3.75. So what we have now, little recapturing here of little recapturing. So what we do is we have our let me just put this here. So little recapturing of what we did already. We have our number block, our equal sign, and our operators. And every time we type a number, we build up a string, an input string, which is this numbers. So we have like 789 versus 789, and as soon as we hit an operand, we add an operator, or the equal sign, we will call our add operand function. And this checks if the display label is not empty, and if it is not, we will use the stuff that's in the display and put it in there, and then after that set the input string to be empty again. So that is a little bit clunky here, because we could just use our input string, which is basically the sequence of numbers we typed, and check if that is empty. So we go in here, put in if not input string is empty. And then we can go in here and say we want the double of our input string. Good. So that looks a little bit better. So after we did that, we do now have this operand in our list. And if we added an operator here, we do this too, and as well add a little addition, subtraction, multiplication, negate, or percent operator based on what we did. So let's make this a little bit cleaner, a little bit a little bit more swifty. And I think then we have it for today, and all the other stuff, all the edge cases we'll cover next time, hopefully. So we have our input string here, and what we do a lot is that we get the input string and we cast it to our just see if we do it a lot really, but we don't. Anyway, we cast it to a double, and another way to do that is to implement a property, a calculated property. So that's a good example for that. So we can define our own variable, which is called input value, and this is not actually a variable per se, it's actually a little function that gets calculated every time we access this variable. So we do return double of our input string if it is possible, if that is actually a string that's convertible to a real number. Otherwise we return 0. And we have to say that we want to have a double here. Not calculator property, sorry, a calculated property. So instead of giving it a value, like we did here, like empty string is the value and we changed that, we have here a little rule which defines every time we access that property how we calculate it. And we use a little bit of snippet of code that transforms this input string into a double if possible, otherwise it's 0. So we can use this now instead of this down here. Instead of doing this in here, we can now use, okay, input value. So this looks a lot cleaner already. So we now see that we have a calculator which we add, where we add an operand from our input value, which is basically the input string as a double. So, but there's more that we could do. Let me just see. Okay, we have now our display label text equals string of blah blah blah. So what we can do now is we can add a calculated property or a setter and getter property, which actually gives us a cleaner way of writing this. So we could define our private variable display value, which is the same as a display string, but it's a real value, and it's of type double. And every time we set something there, so every time we write something into the property, we can instead run our own code. And we want to do self.display label.text is equal to string of the new value. And if we read out from this property, from this display value, we want to return a double from our display label.text or 0. This actually is never called, we don't use that because we have our input string and input value, but I have to implement that because otherwise I couldn't use the set stuff here. So the display value basically does the same as all of this here. So we can write this much cleaner and say that our display value, the stuff that is shown in the display, is the result of us adding the operand to the calculator. And that, I think, is a lot cleaner code and a lot better to read. And now we can do this, and that's why I did it before. Every time we add our operator to this, we actually can do the same. So we can just write display value is equal to whatever the calculator tells us the new value of this stack is after we added the operator. So this way we get rid of these warnings. Let's try that out. 8 plus 6 minus, and that looks pretty shitty actually. Minus 8 equals 0. Why? Because somehow I started with an addition, which is pretty stupid. Eight plus, why? I did mess something up here. Yeah. So what went wrong? The first operand didn't get added to the current stack. That's because I made a mistake. I only added stuff to the input string if there's already something in the if the displayed label is not nil anymore and not null anymore. So I have to do set the input string to be the digit first, and after that I have to set the display label text to be the input string. So what I see now here is that this and this is the same in both, so I can just put this down here and remove this, and this looks cleaner already. So now if the display label text is 0, we set the input string to digit, else we append the input string a digit and then set the input string to display label. But one thing I ask myself is, if I would read this code, and I haven't wrote it yet, if I would read this, I would ask myself, why is he using display label text up here and then just manipulating input string? Why can't he make the decision if he wants to set the input string or append to the input string based on the input string? And actually we can. We can just check if input string is empty. We can do that. We can do that. Let me just see something here. Okay. So if I run that now, I just introduced a new bug on purpose, but it's this one. I can now type zeros, a lot of zeros, which is stupid. But if I go on and type 7, okay, let's just restart it. There's a lot of bookkeeping to do later on. If I type 7 plus 6 minus 5 times 8 minus 3 equals. So this actually looks pretty much like a calculator already. Even though that we have a lot of problems with, like if I go on here, go again, or type plus, oh, this works. Let's see. Let's get it to So it's not really changing the value anymore. And the stack we're building up is pretty huge and pretty wrong. So actually, what we need to do in the next session, we will add stuff for entering decimal numbers, which we haven't done yet, and we will actually add some new function which is reduce, which reduces the current stack to just one operand, so that we can calculate with that on and keep the stack to a minimum level of complexity. So let me just see if there's something I missed. We will also do some number formatting next time. But other than that, I think we have a pretty simple calculator right now. Okay. Thank you very much for joining. I hope you found this interesting, and it wasn't too fast or too chaotic with me. I will upload the file which we just created right after the stream, so you can play around with it. And yeah, I hope to see you next time. And until then, have a good night, day, or evening, depending on where you are right now and from where you're watching. Bye bye.